Okay, so we're going to be talking about network troubleshooting, and we're going to be going over documentation, one of our favorite things, but it is really important. Our troubleshooting process, some of the troubleshooting tools, some of the symptoms and causes of network problems, and troubleshooting IP connectivity. So and when we talk about troubleshooting IP connectivity, we'll be using the layered model. So that's when you'll see how the OSI layers really do come into play when it comes to troubleshooting. So documentation is really important. All of our network documentation should be kept in a single location, and backup documentation should be maintained and kept in a separate location. Something that is really important is when there's a disaster, you should have the phone numbers of all of your vendors readily available to you. You should have backups of all of your stuff. So a lot of times we don't think about our vendor contact information, but that's crucial. We'll talk about our physical and our logical network topology diagrams, our network device documentation, and our baseline performance documentation. So we've got two different types of network topologies. Of course, we have our physical topology, which is what devices do we have and where are they placed, what wiring closet, what building, etc. And then we've got our logical topology, which really talks more about our VLANs, our IP addressing, and that kind of stuff. It's important that we differentiate between the two, and we have mapping of both. There is network crawler software out there that you can use to create the map for you, which is quite nice. Also, when we get into Cisco APIC-EM and Cisco DNA, there's some tools there that can also do documentation for you. So some of our device documentation, our network device documentation, it should have accurate, up-to-date records of the network hardware and software. So we want to make sure that we know what versions of software are on all of our things. And our documentation should include all of the relevant information about our network devices. So the importance of having the software version is simply because there are times when we need to update our software because there's been an exploit and it's leaving us, using old software is leaving us vulnerable. So it is very important to make sure that we have everything up to date. Network baseline. So baselines are basically, you don't know if there's something wrong, and if you don't have something to compare it to when things are normal. So establishing network performance baseline requires collecting performance data from the ports and devices that are essential to your network operation. So it is very important that you make sure that you have something to compare it to, because how else are you going to detect any anomalies in your network? So step one, what kind of data should we collect? We want to start out real simple and then fine tune it along the way. Just like your log files, it's important that you don't collect too much data, because if you collect too much data, then you're trying to find a needle in a haystack, and that's not good. So some good starting variables and interface are interface utilization and CPU utilization. Those would be some good things to start out with. And we want to see, so for example, here we've got the devices and ports of interest, and they include PC1, the admin terminal. We've got two servers, server 1 and server 2. We've got our router interfaces, and we've got key ports on the switches. So those are some of our points of interest that we might want to start out with. And determining our baseline duration. So you don't want to just check it for an hour, because that really doesn't give you a clear indication of what's normal. You want to conduct an annual analysis of the entire network. or baseline different sections of the network on a rotating basis. Your analysis should include should be conducted regularly so that you can understand how the network is affected by growth and by other changes, because your network isn't going to stay the same, right? You're always going to have more nodes being added, and you will have new software being added. One of the really important reasons why you should get very familiar with Wireshark is because quite frequently Wireshark can find if you do a baseline trace, a PCAT trace with Wireshark before you install some vendor specific software, and then you do it afterwards, you can determine whether or not that's lagging your system. So at an absolute minimum, you should do an entire week. It should be no more than 6 weeks, because that's kind of ridiculous. These aren't backups. These are just baseline testing. So a 2 to 4 week baseline is pretty good. And you want to do this annually. So this is our data measurement. This is actually kind of an interesting, cool chart. It's basically listing some of the most common iOS commands that we're going to use for data collection. So we've got our show version, our IP interface, brief, our show interfaces for our details, our show IP route, so that we can make sure that we know our directly connected routes and how they're learned. Our show CDB neighbors detail, don't forget you might want to turn that off when you're done with your baseline. Show ARP for your ARP table, your running config, VLAN ports, and tech support. So I'm used to show a large amount of information using multiple show commands. So that's kind of cool. So our troubleshooting process, this hasn't changed much since the days of A+. We've got the same basic process. So first we want to gather our symptoms. We want to use a structured troubleshooting method. It's going to shorten our overall troubleshooting time. If you're a good systems administrator, or network administrator, you're not going to be running around with a fire extinguisher all the time, putting out fires. You're going to maintain your network and keep things running smoothly. But there are those instances where things break. So there's several different troubleshooting processes that you can use to solve a problem. And this is a logical flow chart of a simplified 3-stage troubleshooting process. You're going to gather your symptoms, isolate your problem, and implement your corrective action. And if that didn't work, you're going to try something else. So we've also got a 7-step troubleshooting process. And basically, all of these are doing the same thing. Some of them are minimizing some things, but basically you're just trying to figure out what is the problem, getting information about it, analyzing it, and eliminate some, keep it simple. Go with, what you really think might be the issue. For example, if you have connectivity problems, what would be the first command line tool that you would use to determine that? Anyone? So I would do an IP config all. If I was on a PC, I would do a ping.
Ping.
Yeah, if it's end to end, I would do a ping a URL to make sure that my DNS was resolving. So just your basic, I guess the first thing we probably should have done was check for our link light, right, to make sure it wasn't layer 1. But yeah, these troubleshooting processes do get much easier the more you have to implement them. The more you learn, the better you are at figuring things out. Questioning your end users. When they say, I don't know, it just doesn't work. It just doesn't work. Well, what doesn't work, And that's why as techs, if we have to call tech support, we get so annoyed because they have a flow chart of questions that they ask all of us, and they have to ask us that script. So normally, if I'm talking to tech support, I will already tell them all the things that I've tried just so that they don't think that, you know, so that I'm not wasting their time, they're not wasting my time, right? But your open-ended questions are really going to be relevant. And sometimes your network problems could be as simple as, maybe there was a power outage or a power failure on one of your switches, or somebody unplugged something accidentally, you know? Um, so if anybody can reproduce that problem, that's great. What's changed since the last time it worked? These seem more like our A+ questions, don't they? But they're just as relevant here. So you want to, do your own research. You've got some good Cisco iOS commands that you can use to gather your problem symptoms. So your ping, trace route, telnet, can you SSH, as opposed to telnet. The one thing that telnet and SSH does, though, is it does check higher up the OSI model. So the telnet and SSH will be testing at layer 7, your application layer, as opposed to just a ping, which doesn't. Show your IP interface, make sure that you've got, correct IP addressing, show your protocols, and debug. So the more information that you can get, the better. And here's some of the common devices and the OSI layers that have to be examined during the troubleshooting process for that device. So our physical layer would be our hub, our cables. Data link layer would be our standard switch. Network layer and transport layer would be our multi-layer switch or router. And then our end system could be session presentation or application. So, and I think more often than not, we're going to be shifting to the TCP/IP models as opposed to the OSI model, just because so many of the presentation session things have been built in to the application layer. So our troubleshooting methods. So there's different ways that you can approach a problem. You can do it bottom up. So you start out at layer 1. Have you got a link light? How's your cable? Or you can do top down if you think the problem is software. Divide and conquer. You just start in the middle. You could do follow the path. So you can check the actual traffic path to determine the problem. So different troubleshooting approaches. It just depends on where your head is at and what you feel most comfortable with. The educated guess is going to be down the road for you guys when you've been doing this long enough that you really have a good background analysis of troubleshooting tools. And a good example of that is in the A+ class. Daryl, he was having issues. He couldn't access Word. He could access Excel. He could access PowerPoint. He couldn't access Word. It kept on giving him an error. And I looked at the error message and it was just really vague. And I was like, okay, so have you tried uninstalling Office and reinstalling it? And he said yes. And I was like, okay, that's interesting. And I said, well, so when you uninstalled Office, did you use this tool or did you just uninstall it? Because sometimes it overwrites so sometimes if you don't uninstall it first before you reinstall it, then it doesn't overwrite the garbage. And it ended up that so he had done all of the things, and I had been all over Google and sysadmin, Reddit, and everywhere trying to figure it out, and I couldn't find anything. I had the event viewer error code and everything, and just could not figure it out. And he even uninstalled Windows and reinstalled Windows, and then reinstalled Office, and still was having an issue with Word. Which at that point, of course, it was like, well, you are using a different version of Office, right? You're not using the same ISO of the software that, because maybe it was a corrupt version. But he had previously used it, and it was fine. So it comes to find out that his real problem was his NVMe had gone bad. I had suggested check disk, you know, and had never even dawned on me because I haven't had enough experience with NVMe to jump through all those troubleshooting, you know, processes. So now I've got some additional information for in my back pocket for troubleshooting NVMe. So you're never going to stop learning. Yay. You won't get bored. And the more you know, the easier it's going to be the next time. Because that will definitely be one of the questions that I ask, right? Do you have NVMe? And check to see if in your BIOS what SMART says about it. So guidelines for selecting a troubleshooting method. So this basically illustrates which method could be used when a certain type of problem is discovered. Troubleshooting is a skill that's developed by doing it. And like I said, you get better and better at it the more you do it and apply it. Each network problem that you identify and solve gets added to your skill set. So now we all know about NVMe and some of the peculiar errors that it can create. So our troubleshooting process. So some of our troubleshooting tools would include our network management system tools, knowledge bases, and our baselining tools. Protocol analyzers. As I said previously, Wireshark is your friend. It is absolutely wonderful. It can capture and display the physical layer to the application layer, all the information that's contained in a packet. So if you end up being a Wireshark guru, you've really got things going on because you know in excruciating detail, you can look at a network underneath a magnifying lens and see exactly what should or should not be happening. There are some free Wireshark courses out there. I would strongly suggest that you become very familiar with Wireshark because it will make your troubleshooting life so much easier. So some of our hardware troubleshooting tools, we've got lots of those. We've got our multimeters and cable testers, cable analyzers. We've got our portable network analyzers, and we've got Cisco Prime NAM, and that's a browser-based interface that basically is going to check the performance analysis in your environment. Our syslog server. So we're going to have lots of log files, and we're going to have them all sent to one particular syslog server. You know, that just makes it way easier for us to determine, you know, the health of our system and what anomalies are available. We don't want all of the data, right? We don't want information. We don't want notifications. We may not even want warnings, but we're going to want errors, critical, and alerts. Alerts and emergencies, your phone's going to ring probably. So if you can catch something, if it's a warning or an error, you know, perhaps you can fix the problem before it gets out of hand and becomes something terrible. So physical layer troubleshooting. So performance lower than baseline. So sometimes that can be a kinked wire. There are some actual 802.3 specifications regarding not bending a network cable more than 45 degrees. There are specifications regarding how you're going to manage your trunks of your network cables. So you definitely you don't want to abuse cables in an installation. When you're pulling wires, doing an installation, if you pull them too fast, not only could you kink the wire and rupture it, but you could also, you burn the insulation off if you pull it too fast. And I've seen this happen before, where somebody has burned the cable that they're pulling is just fine, but the cable that it was next to in the trunk ends up, the insulation gets burned because of the friction. So loss of connectivity, check that with a ping test. Network bottlenecks or congestion, so it could be routing protocols, high CPU utilization, see what problem that could be, and of course check your error messages for sure. Power related, your fans and your power supplies are not going to last forever in your equipment. Hardware faults for NIC drivers could be a problem. Grounding problems, cabling faults, so damaged cables are quite frequently a problem. Attenuation, there's a reason why there's a specific length for a cable, and that's because after a certain point, the signal gets degraded so poorly that it is corrupt. So do not exceed the standard recommended lengths for your cables. Make sure that you have a switch or something in between to regenerate that signal and pass it along. Also dirt or oxidized contacts. Line noise, so you've got your EMI, right? So it could be EMI or RFI, any of those kind of things. High voltage, those can cause problems. Interface configuration errors, so that would be all on you. So incorrect clock rate, clock source, an interface not being turned on. Perhaps it was a sticky port on a switch, right? You have port, excuse me, you have port security enabled, and somebody plugged something into that switch that they shouldn't have, and it got shut down. Well, in order to bring that back up, you may have to administratively shut it down and then bring it back up. And exceeding design limits. And that could be as simple as your wireless access points and expecting the signal to go further than it's supposed to. Excuse me. So some of our data link networking problems could be maybe frames aren't taking a good path. Maybe your operating systems are using broadcasts and multicasts excessively. When a NIC goes bad, it will broadcast incessantly. So that could be, so check that. Also, if you plug a network cable from one end of a switch from one port of a switch back into another port of a switch, you've created a routing loop. We've created a loop, and spanning tree protocol will just blow a gasket. So that will also propagate your broadcasts. Your messages. So hopefully you're going to get some good messages that will let you know what problems there are. Other problems could be encapsulation problems, address mapping, so framing errors, and of course, spanning tree protocol failures or loops, as I had said, can be a real problem because it will just infinitely create more and more broadcasts. Let's see. So for network layer, that could be, that's network failure is going to obviously, your phone will definitely be ringing. But perhaps it's just suboptimal performance. Maybe there's something going on that's different. Maybe there's a different type of traffic. Perhaps your switch is accustomed to just normal data being transferred, And now it's all Zoom conferencing. It's all, video data, which is going to take up a lot of your performance. So other network issues could be anything from, your connectivity issues, your routing table. So routing tables do get full. And that's why it's a really good idea to do, what were they called? Super netting. So when you're dealing with super netting, it's just putting one entry in your routing table for a number of networks that were subnetted. So let's say I have 192.168, 192.168. I don't want to use that. Well, let's just say we've got a number of contiguous networks, subnetworks. We can take the first subnetwork and the last subnetwork and supernet all of the networks that are in there and just put one entry into your routing table for that. Checking your neighbor adjacencies. Don't forget other things that would probably be layer 2 would be duplex, full duplex or half duplex, or if you've got it on auto negotiate when it shouldn't be. So check your topology database, check your neighbors, your access control lists can definitely be a problem. So make sure that you're checking it for the correct direction of flow. Check the order of your access control entries, right? If you deny before something gets approved or gets permitted, no, it's not going to get permitted, because once it gets denied, it gets thrown out and it doesn't get looked at anymore. So make sure that you have your access control entries correct. Don't forget you have an implicit deny any at the end of that access control list. As soon as you create a permit something, you have an implicit deny for everything else. So make sure that that you're aware of that. Your IPv4 wildcard masks, make sure that those are correct. Make sure you're using the correct protocols and ports. And if you're using a keyword, make sure that you're using it properly. And be on the lookout for odd protocols, which I'm not too sure which protocols those would be. Network address translation, something to think about, right? So for network address translation, these are some of the problems that you might have. So these slides are really great slides for you to hang on to, because this chart definitely tells you, oh, it's a problem with this. Oh, it's a problem with that. This is what you should do. It definitely helps narrow things down. Tunneling and encryption protocols are an issue. SNMP, so your network management protocols. And don't forget that some protocols get exploited. And so you need to be familiar with the vulnerabilities of those and make sure that you're using updated protocols. With application layer troubleshooting, you should never use Telnet, right? We know that. Never use Telnet. But SSH. So if you're using SSH, then you know that the entire stack is working from 1 to 7. All your layers are great. HTTP, FTP. So some of those are application problems and some of them might be network problems. Perhaps you have an access control list that isn't allowing a specific application protocol. So all those things need to be considered. If you don't know, and a lot of times your vendors will say, hey, you have to use port yada yada, right? And so that's documentation that you need to be aware of, and make sure that you open that port for that protocol in the proper direction. So troubleshooting our connectivity. Check your physical connectivity, check for duplex mismatches, your data and network layer addressing. A lot of times it could be just a fat fingered IP address. Check to make sure that your DHCP server hasn't run out of addresses, right? If it's an addressing issue, make sure that you've got the correct default gateway. If you can't ping through a switch, why can't you ping through a switch? Because you don't have a default gateway set on that switch. So it's a layer 2 switch. Why do I need an IP address in there? Because we need to put a default gateway on there. Otherwise, we can't ping through it. Make sure that your transport layer is functioning correctly. Check your ACLs. You know, and particularly pay close attention to, you may not be in charge of all the things. So if you have somebody else on your team that is in charge of access control lists and firewall, ooh, we just got this new hardware appliance, firewall. You know, those are things that you need to be aware of and need to communicate with the rest of your team so that you know that you're not beating your head against a wall. And a lot of times the problem might be the vendor, but the vendor will never immediately say it's them until you've already proven that all of your stuff is fine. So a lot of times a software update will break things from your vendor. So usually what initiates a troubleshooting effort is discovering that, yeah, there's a problem between point A and point B, right, from end-to-end connectivity. And of course, the first thing that you're going to play with is going to be ping and trace route, because those are just the logical first steps, right? Absolutely, logical first steps. And then we've got the physical layer. So some of the things when we do a show interface, and that's the full show interface, there's a lot of information there, but the things that we really are interested in is our interface status, our input Q drops, output Q drops, input errors, and output errors. So those are the things that we're going to want to pay close attention to inside of all of the immense amount of detail that we get from our show interfaces. Check for duplex mismatches. So IEEE 802.3 AB gigabit Ethernet standard mandates the use of auto negotiation for speed and duplex. And practically all fast Ethernet NICs are also use auto negotiation by default. So problems can definitely occur if there's a duplex mismatch. If you're using brand new equipment that's on auto negotiation and older equipment that isn't. So make sure that you've got both ends of that cable. Remember, there's two ends of a cable, so make sure that both ends of those cables are using the same standard. Your IP addressing. So we can do ARP to check our ARP cache. You know, we're going to use an ARP-A to check all of the things to make sure, because it's going to display and modify displays and modifies our entries in ARP cache. So we can check to make sure our IP addresses are then resolved to their MAC addresses. And VLAN assignments. Remember VLANs? Yeah, so VLANs could be an issue. So you want to check your VLAN assignments and make sure that the VLANs that you're connecting to are actually, the port that you're connecting to is actually a member of that VLAN. So you can't just plug a cable into a switch and expect it to work just fine, right? Because you need to double check and see which ports belong to which VLANs. And our default gateway is most definitely like one of the most common. So some of the ways that you can verify your default gateway is on router 1, you could do a show IP route. On PC 1, you could do a route print or a netstat -R. And just to make sure that everything is kosher. So because router 1, the default gateway is 192.168.1.2. And that's to router 2. And PC 1, it's 10.0.1.10.1. on router 1, that would be attached to G000. Don't forget, there's 2 ends of a cable, and we need to make sure that both ends are correct. So our IPv6 default gateway, it can be configured manually, or it can be configured using Slack or by using DHCP56. So make sure that you've got that correct. Do our IP unicast routing, and then check your addresses. Make sure that we're verifying the path. So here we're looking at the process for both IPv4 and IPv6 routing tables. The process of forwarding our IPv4 and IPv6 packets is based on the longest bit match or the longest prefix match. So the routing table process is going to attempt to forward the packet using an entry in the routing table with the greatest number of leftmost matching bits. And the number of matching bits is going to be indicated by the prefix length of the route. A common tool for testing transport layer functionality is Telnet. You know I hate Telnet, but it can test your functionality. So this is something that you might want to enable, try, and disable immediately. Because with Telnet, you don't have to think about encryption or authentication so much, right? Maybe the administrator here is attempting to Telnet to router 2, and it's using port 80. And it's saying that you can't get through. I would still prefer that you guys use SSL or SSH. That would be way better. So checking your access control list. So of course there might be ACLs that prohibit a protocol from passing through the interface, and whether it's going inbound or outbound. So make sure that you check ingress and egress to make sure that it's all, that your access control list is working properly. Verify your DNS. So when you configure DNS on the device, you can substitute the host name for the IP address and with all of the IP commands like ping or telnet. So ping a URL or telnet a URL, and that way we can tell that DNS is working correctly. If it's resolving, then we know that that's good. You can use the IP host global config command to enter a name to be used instead of the IPv4 address for the switch or router. So that's showing you how to do that. And you can use, don't forget, you can always use NSLOOKUP to display the name to IP mapping information. So we've got a bunch of troubleshooting packet tracers for you guys to work on. Just think of them as puzzles. So we went over network connectivity, compiling our host address information, our remote access default gateway issues, some of the devices on the network, and making sure that you have a network topology that is adequate. And, you know, there's absolutely nothing wrong. There's no reason why you couldn't do the network topology in Packet Tracer. That would be another way that you could implement and keep a backup of your network configuration. And that would be also a good way for you to be able to troubleshoot the problem, you know, and see what happens if you break this, what happens if you break that, and see if you can duplicate the problem or replicate the problem in Packet Tracer and then try and fix it. But yeah, nobody's ever going to call you and say, hey, everything's wonderful. Oh my gosh, you know, thank you so much for keeping the network up and going. It's just wonderful. They're going to call you when something's wrong. So as I said, lots of Packet Tracer troubleshooting. This one you're looking at the documentation. So I would be looking at IP addresses and some of those kind of things. And there was a lot to digest, but troubleshooting is a lifelong process. And there's lots of tools that you can use to help you out. Baseline tools, protocol analyzers, you know, r/networking in Reddit. They're wonderful. CCNA in Reddit is okay. So yeah, it definitely there's lots of help out there. And there's different ways that you can approach your troubleshooting methodology. You find what works best for you. I would strongly suggest that when you're starting out, you start out with the bottom up troubleshooting approach, because it's really dumb to start out at an application when it's really a bad cable. It's like you're spending so much time, start out with the basics. Like, is it plugged in? Is it turned on? Is there a cable that's good? Replace the cable, see if that does anything. And then take it from there. The end.
So you're telling us to check for the light and then do a ping.
Yeah, pretty much. Check for the light, and sometimes just replace the cable, check the cable. I'm going to